For population growth, we're going to look at two graphs. We're going to look at exponential growth or unrestricted growth and logistic growth or restricted growth. We're going to look at the population size over time. In exponential growth, the population is under perfect conditions. They have unlimited resources and they're going to grow. So that population is going to get larger and larger. There are no limiting factors. They have plenty of resources, plenty of food, plenty of space to grow. So that population is going to get larger and larger. When we look at the graph, typically the graph is going to be in a J shape. So if you look at our graph here, the general shape of your data is in a J. If we take a look at another example for the elephants, you'll notice that the graph is in the shape of a J and the population size is going to grow. It's going to get larger and larger. Now in nature, exponential growth cannot continue for a very long time. As resources become less available, that population growth is going to slow down or it's going to stop. Logistic growth occurs when a population's growth is going to slow down or it stops. Typically, the graph is going to look like a stretched out S. So if we take a look at these three graphs on the bottom of the slide, you'll notice that the growth of the population, it starts to slow down, it starts to level off. This point where it starts to level off is called the carrying capacity. So carrying capacity is the maximum population size that an environment can support with no impact. Carrying capacity on a graph sometimes is represented as the letter K. When we take a look at this top graph over here, we're looking at the population of seals. So if we follow our graph along the line here, when it starts to level off, this is the carrying capacity, and that is in about 10,000 seals.